Once a large-scale failure occurs in the ICT system that supports social infrastructure, its impact is crucial. Therefore, it is important to identify the faulty devices and recover from the failure. In particular, in a large network in which various devices work together, a failure generates a massive amount of observational data, such as alarms and logs. Manually identifying the faulty device from these data requires considerable time and labor. Currently, the faulty device is estimated using if-then rules, which are created in advance to associate observational data with faults. However, since a large number of rules are required, their creation is a heavy burden on operators. Furthermore, the rules are ineffective if unexpected observational data arise. To solve these problems, NTT laboratories are developing a technology for estimating a faulty device for atypical failures. It eliminates the need for rule creation and is effective even for unexpected faults. Let's see how this technology estimates the faulty device. First, the relationships between device states and observational data, such as alarms and logs, are represented in the form of a causal model using a Bayesian network, which is a type of probability model. The model is created based on the network topology and past failure data. The faulty device is estimated using this model. For example, consider a case where alarms Y3 and Y4 are observed. First, the fact that alarm Y2 is not observed is reflected in device state X1 and X2. At the same time, the fact that alarm Y3 is observed is reflected in device states X2 and X3. Next, X2 calculates the probability of its state being normal or abnormal by taking account of the observational state of alarms Y2, Y3, and Y6. The calculation result is reflected in the observational states of alarms Y2, Y3, and Y6. Similar exchanges are executed between other observation data Y and the states of other devices X. After these exchanges are repeated many times, the probability of each device state X being normal or abnormal converges. In the end, the final probabilities of candidate faulty devices are calculated. To adapt to unexpected peculiar events, this technology not only calculates the probabilities, but also simultaneously modifies the causal model by adding or deleting edges in the model repeatedly. In addition, the model modification is done by considering the concept of modification penalty to ensure that the modified model does not deviate from the original model. This technology can be used in conjunction with anomaly detection technology called Deep Anomaly Surveillance, DANOS. DANOS estimates the major cause of an anomaly, and the faulty device estimation technology uses this result as input data to quickly estimate the faulty device. In this way, this technology can be used to identify a faulty device from the anomaly detection result produced by DANOS. Looking forward, NTT Laboratories will combine this technology with a technology for suggesting recovery procedure in order to achieve a one-stop solution that detects a failure and finally suggests recovery procedures.